Okay, in the previous video, we talked about the domain restriction. So remember, the inside of any type of radical equation must be at least positive or zero. So if the inside is greater than or equal to zero, I guess the root of that inside must produce also positive number. So you kind of have to recognize that something's not right. Like root of this expression is negative, but let's just say you go along and try to solve for the x value. So we're going to square both, because in the previous video we talked about the square taking out the root. So 5x minus 4 is positive 1, because negative 1 times negative 1 is positive 1. So just keep on going, do your algebra, and then you're going to notice that 5x is 5, therefore x is going to be 1. And you might be thinking, okay, what's wrong with this answer? Well, we have to check for the extraneous root, and the way you do it is to go back to the original equation, which was given like this, where we kind of thought that, okay, how come the inside of the positive is producing the negative? Well, let's check and see. So we're going to put in 1 into the equation and then go 5 times 1 minus 4, and the question mark is going to be, is that indeed negative 1? So let's see. 5 times 1 is 5 minus 4, and I'm still asking myself, is root 1 really negative 1? When 1 is root 1 and negative 1. And obviously this is not true. It is false. So now you're thinking, then what is this? We got this number 1 as our answer. How come it's coming out to be false? So we call this the extraneous root. It just means that algebraically you can get the solution, but when you put it back in, it is kind of telling you a lie. So it's not valid. So you reject it. Therefore, overall, there is no solution to this equation. We can actually check this on Desmos if you like. So the original equation was root 5x minus 4. And then because I'm putting it into Desmos, I'm going to move negative 1 over, and then it's going to be plus 1. So if there was to be a solution, it has to be anywhere touching point the x-intercept on the x, but we don't see that. There's no x-intercept, therefore there's no solution.